Hi, I'm Colin, and this is our CS184 final project to create super realistic natural terrain. This is what we started with. It creates the terrain, but it's not very realistic. We want to make it realistic by adding reflections in water, fog, grass, a surrounding environment, and make it more visually appealing.
Hi, I'm Ian, and I help implement a shader to render fog in a scene based on the distance of the fragment to the camera. I changed the fog factor based on whether it was a linear fog or exponential, and interpolated between the fragment color and fog color based on this factor to achieve the final vertex color.
For the grass, at a high level, we crisscross 2D billboards at every vertex where we wanted grass to render. This is more efficient than rendering a single grass blade per vertex, and we made it more efficient by only rendering grass within viewable distance. Most of the work happened in our geometry shader, which emitted the extra vertices to create the billboards and transformed the grass vertices into camera space.
Hey, I'm Satvik. We also implemented a different kind of grass shader for the snowy terrain. Three main differences being the regular grass and our snowy grass are at different Y values, the snowy grass being at the height of the snowy zone. Two, the snowy grass only appears sparsely to resemble a more realistic snowy terrain based on a specific probability factor. Finally, we created a separate texture itself differing from the original grass to give it a more snowy look.
Hey, I'm Zach. At the start, we began with a single mesh per chunk of terrain, the dark blue representing the portions of water. Then we introduced horizontal planes of water that cut through the mesh at each body of water. In the next slide, we can observe that we implemented reflection, and refraction. It's time to texture. With each of these effects, you do one rendering of the scene, one above the water's surface and one below the water's surface for the reflection and the refraction texture respectively. In the next slide, we also added distortion and movement. This was done by texture mapping a DUDV map, as well as displacing our texture coordinates from the previous slide by a value proportional to our number of renderings mod 1 to provide a flow of water that cycles like a pattern.
We also wanted to create a more realistic sky, and we did this by creating a cube map and stitching together 6 different images. And this time we used 3D directional vectors to choose the correct face and using the original UV coordinates to sample along that face. And we made sure to replace anything that's not been set in the buffer for faster and more efficient renderings.
Through the implementation of fog, grass, and water rendering, we developed a deeper appreciation for the complexity and effort required to achieve visually appealing and realistic graphics in video games. We gained hands-on experience with OpenGL and its programmable rendering pipeline, including vertex shaders, geometry shaders, and fragment shaders, and using them to create the realistic effects like reflections in water. Thank you.